Hello guys, welcome back to the channel. And so we are gonna start with our new data structures called linked list. And so what I have did here is that I have moved all the problems to the code forces section, and you can find in another package called code forces. So I have created a new package called linked list, and I'm going to talk about all the linked lists. So in my channel I have created a playlist about linked list, and I will be adding all the videos and all the basic problems to the advanced problems which I can or I might not be able to solve at the first attempt, but I will be adding all the problems there only, and you can find all the linked list related problems to that. And now I will be talking about the linked list. So let's just talk about the linked list. I have written the post pretty much early about linked list, but I could not cover up the video and due to that strict schedule. And yes, I think I might not I might not waste time, and let's just start. So linked list. Linked list is a list which is formed by linking the elements together. So basically, a linked list, when you segregate that into two words like linked and a list, so you can find the basic meaning that it gives that linked and list. So it's a linked. Like some object or something is linking in this list, and these all linking of the elements are forming a list. So linked list can be thought as an data structures which has a collection of elements which are linked together. So it's not a contiguous locations. What do I mean by contiguous location is that you have heard about the array data structures, and array data structures are linear data structures where all the memory addresses are like if you have an integer type of array list, array data structures, then you have um, plus 4 bytes of address. So you have a of 0 element at 100, and a of 1 element at 1004, and a of 2 element at 1008. So you can find all the uh, memory elements at the contiguous location in the all the elements at the contiguous locations in the memory. While linked list is not stored at contiguous memory, you have the first element stored at some address xyz, and the next element at something like abc. I am not, these are not the memory address. I am just giving you the reference that these are not contiguous, or you cannot find a relationship between the memory elements of these linked list elements. So that is linked list. So why do we prefer and why do we not prefer linked list? Because like in array, we can not add or remove elements in the middle. We can add or remove elements in the middle, but it takes more cost. And while in linked list, it takes less cost. So linked list is useful for solving where indexing based solutions are not feasible, and linked list does not have a size complexity, while an array has a predefined size until you are not using the dynamic arrays. You have to define a size of a array, which might lead to a problem of like when you need more memory than you have allocated, or you are wasting some sort of memory in the array. So yes, while linked list is consist of a node, and you have an extra next pointer memory address. So that is not done in the array. So that is basically the difference between an array and linked list, that linked list considers next pointer at every node. So next is it takes linear times for traversing to the last, and that means you do not have any contiguous locations, and you cannot find any relation between the first element and the second element memory addresses. So you cannot just traverse to the last like in linked list, but like an array list. But in linked list, you have to just traverse from the 1 to 3 to n. So you have to move all the way around to travel to the last. So and the next is that linked list is also storage is allocated at runtime. So I think that is all about the linked list. Let me just draw the structure of a basic linked list here. Um, a linked list is a pretty much of this type of skeleton where this is the next pointer and this series follows. So this is the linked list. You can store any type of element here, and yep, you can store anything, and you have an head pointer which points to the first element of the linked list. Okay, and yep, so and this specifically represents a node. A node has an element and the pointer to the next element in the linked list. So linked lists are of following types: singly linked list, doubly linked list, circular linked list, and skip list. So I will be covering all these linked list and like in the future videos. And yes, you can read this blog post, and the blog post link is @codedsense/linked list simplified, and you can have the gist of what is linked list all about. So I have also added a basic representation diagram where a node is containing an element and the next pointer, and the next is pointing to the next node element in the linked list. So that basically this whole is known as the linked list, and this is a particular node and this is another particular node, and the series of nodes forms a linked list. So yes, I have also drawn here the linked list, a collection of nodes, and a node is a collection of element and next pointer. So yep, now here I have given a specific example of a node, and what is exactly is a node in a linked list. I will just cover that in the here in the editor, what is a linked list. So I have also given the implementation of a generic linked list, what is linked list and how do you create a linked list. So basically these are the basic functions: searching, traversal, insert and deletion, and length or loop. Or you have to just find what is linked list and what is like what are the you have to find the cycle in the linked list. You have to find the nth element from the last of the linked list. There are many such problems in the of the linked list, and I will be covering it all if I can. And yes, I will be targeting that. And so basically this is all about the linked list, and I think I will be like introducing the linked list in the next video. It was all about the introduction and what is linked list all about. So I think that clears about major section of linked list. And if you are a beginner or a noob, because previously back in the years when I was being like introduced to the linked list, so I was very much terrified about what is linked list and what problems does it actually solve. So majorly linked list is considered over arrays in some problem solving sections, because linked list is like very much dynamic in size, and like you have access to like all the specific memory elements, and you can just add or remove with a very less cost as compared to arrays. Now let's just give me an example. Like if you have an array and 5 6 7 10 12, and you have to just like it has a length of 100 elements. Okay, like it has this length of array 100 elements. Now if I said that delete the middle element, that the 50th element, uh, let's assume that it okay, so let's assume that 50th element is 12. So you have to delete it from the array. So now what will you be doing is that you will be traversing to the 49th element, and then you will be deleting the 50th element as null, and then you will be moving all the pointers from 51 to 50. So I think it creates an extra cost. Will be moving 51 to 50 and 52 to 51, and you also waste an extra memory space at 100 position. I think that makes sense. So to save that cost here, what I suggest is that, and what usually people do is that you just create a linked list, 5, 6, and no matter how much length, let's say 12. And you just, what you do in the linked list here is that you just take up the pointer from the previous element here, let's say it's 11, and you just takes the pointer of the next element here, and you just point simply this pointer to this next pointer, and you just delete the memory element by assigning it to null. And you do not have like uh, any extra movement of the elements like in arrays, and you do not have any extra wastage of memories because null is assigned to this element, and the garbage collector of Java is very good. It collects automatically, grabs that and will collect it. So yes, this is the basic advantage of linked list, and I will also be exploring more advantages of linked list as I will be solving more problems. And so yes, starting from today, this is the new topic, and this is our new data structure called linked list. Let's see how we do that and how we are going to scale this. So by linked list, I will be covering. I have a very like a good plan to cover all the data structures majorly, but yes, the time sometimes is not allowing me to perform and like record videos and give too much time. So okay, thank you guys, thank you for watching, and more linked list videos coming soon. Thank you.